Hi, we're going to work in triangulation today, and we're going to work triangulating from elevation view, which is different from what we did last year from plan view. So we're starting out, we have a elevation view here. We've got a squared around figure, and we're going to work with a technique or method called difference in profile. Now when we start working this one of the first things we're going to do is put profiles on each end, like that. Now what the profiles are is a indication of how far that fitting is coming out. So again, if we looked at this one, the representation of these is how far the depth is in any fitting. So these ones have been folded down to show us what those look like, but that's really what we're representing. That's there, that's there. And where the difference in profile comes from, it shows us how far any item is leaning over in the view that we don't see. So if we imagine looking at a side view of this one, we might see something like that, okay? Now with difference of profile, what we do is we take any line from one profile and we compare it to the other profile and see what that difference is. So if I took a line from here, I put it down on this one, always coming from the back side in, leaving the difference up here. Okay, and when I do that, I'm sort of taking away the equal portion of those. So if I take this one and put it down here, I'm left with the difference here. And the difference is going to give me the true length. That's the hypotenuse I want. So if I went in anywhere else, it's not going to be a true representation of how far that line actually leans. When I bring the small profile down and minus it off the large one, it leaves me this little triangle here. So the same idea is used here. I can take this line, it's leaning out that far if we thought of it coming this way. Take it off this one and maybe it ticks off here somewhere. That means this is the difference in profile. The difference of it, it's leaning this far at the top and it's leaning that far at the bottom, and the difference gives us the true length. That's an important concept when we're triangulating from elevation view, because we don't have that depth. When we're working from plan view, we knew how far it's leaning over. We know right here or right there. Any of those element lines that we draw in there, we know how far it's leaning because we're looking directly down on it, and we see that depth exactly there. And that's one of the lines that we would have used in our true length diagram. So this process a little different. We're going to go over in depth, but that's sort of the prelim. That's sort of the beginning steps of it. We're taking one profile compared to the second profile, and the difference in profile is what we're looking for. That's what's going to give us the true length of any triangle. Thanks.